This video, we're going to talk about supplemental examples from 7.3, where we talk about the shell method, and we are going to also compare the shell method with the dishwasher method and see that we can get the same answer and see which method was easier for our problem. So let's go ahead and look at this one first. If we factor this one, it's going to be negative x times x squared minus 1 is a negative x times x plus 1 times x minus 1. So our graph is going to cross the x-axis at negative 1, 0, and 1. This goes down and to the right, up, down, and back up. It's symmetric about the origin here, and I'm interested in this region right here between 0 and 1. And I'm going to be revolving around the y-axis here. My representative rectangle is going to be vertical. It's parallel to the axis of rotation. So we have v is equal to 2 pi integral 0 to 1. Distance to the rectangle there is x. Height of the rectangle is x minus x cubed dx. V is 2 pi 0 to 1 of x squared minus x to the 4th dx. V is 2 pi x cubed over 3 minus x to the 5th over 5 from 0 to 1. It's 2 pi times 1/3 minus 1/5. When I stick the zeros in, this is zeros that I'm subtracting and adding. So that's 2 pi times 5 minus 3 over 15 is 2 pi times 2 over 15 is 4 pi over 15 cubic units because I'm talking about volume. All right. Next question here, use the shell method to write and evaluate the definite integral that represents the volume of the solid generated by revolving the plane region about the x-axis. Picture included here. Note, is the dishwasher method more useful here? Absolutely, because we could have perpendicular rectangles and only have one function and not have to do two integrals. Do you get the same value for the, I should say, volume? For the volume. All right, so y equals 1 over x is this function from x equals 1, 1 to 2 is 1/2 there. And so using the shell method, I have 2 pi from y is 1/2 to y is 1 of y times 1 over y minus 1 dy, and plus 2 pi from 0 to 1/2 of y times 1 dy. So y is my distance here away from this axis of rotation, but I am actually going to have a washer idea going on here. So going to be subtracting here to get my radius. It's like if I shifted it down 1. So anyways, this is y times 1 over y is 1 minus 1 over y dy. It's 2 pi 0 to 1/2 y dy. So this is 2 pi It's going to be y minus ln of the absolute value of y from 1/2 to 1 plus 2 pi. This is going to be y squared over 2 from 0 to 1/2. So this is 2 pi times 1 minus 0. Minus 1/2 plus ln of 1/2 plus 2 pi times 1/4 over 2 is 1/8 minus 0. So this is 2 pi times 1/2 minus plus ln of 1/2 plus 1/8 is 2 pi times 5/8 minus ln of 2. Okay, that's exactly what I get. Why did I say 1 over y? This is y. So this is going to be y squared over 2. And that is, this is 1 minus 1/2. And then minus 1/2 plus 1/8 plus 2 pi times 1/8 minus 0. Okay, so 1 minus 1/2 minus 1/2 is 0. We have pi over 4 plus another pi over 4 is pi over 2 cubic units. That's what I wanted. All right, now let's do it instead with the disk method here. Should be easier. Pi 1 to 2 on x, 1 over x squared dx, pi 1 to 2 of x to the negative second dx is pi x to the negative first over negative 1 from 1 to 2 is a negative pi 1 over x from 1 to 2. Negative pi times 1/2 minus 1 is a negative 1/2 is pi over 2. And again, this is units cubed. So we get the same answer both ways. I think that the disk method, the washer method, was extremely easy there. Use the disk washer method or the shell method to find the volumes of the solids generated by revolving the region, bounded by the graphs of the equations about the given lines. So x cubed to 2, 8, starting at 0, 0 down here, and so we're talking about this region right here, bounded by y equals x cubed, y equals 0, and x equals 2, revolving first around the x-axis. So, and looks like we can get vertical rectangles there. They'll be perpendicular to our axis of rotation pretty easily. So we'll use the disk method here, and we'll have pi 0 to 2 r squared dx is pi 0 to 2 of x to the 6th dx is pi times x to the 7th over 7, evaluated from 0 to 2. That's pi times that's 2 to the 7th over 7 minus 0 is a big number. So 128 over 7 pi. Cubic units. For B, and we want to rotate that now about the y-axis. Easier to use the shell method there. Keep that representative rectangle the same. And we're going to go 2 pi shell method. Distance here to the rectangle is x. Height of the rectangle is x cubed dx. X is going from 0 to 2. So this is 2 pi 0 to 2 x to the 4th dx is 2 pi x to the 5th over 5 from 0 to 2, 2 pi over 5, 32 minus 0. 32 times 2 is 64 pi over 5 cubic units. And about the line x equals 4, so that's going to be over here. X equals 4. And we want to use the shell method again for this. This is 2 pi 0 to 2 of, and now this is going to be, the distance here is going to be 4 minus x. So 4 minus x for the distance times my height is x cubed dx. So that gives me 2 pi integral 0 to 2 of 4 x cubed minus x to the 4th dx. 2 pi x to the 4th minus x to the 5th over 5 from 0 to 2. And that is 2 pi times 16 minus 32 over 5 is 2 pi times 5 times 16 is going to be 80 minus 32 over 5. 2 pi times 48 over 5 is 96 pi over 5 units cubed. All right, and that's it for this video. Next time, we will come back and talk about supplemental examples from 7.4. See you for the next video.